All right, so unit 13 is all about breaking everything we've learned together. And we're going to do simple interest here. And the simple interest is a linear equation. Linear equation. It may not look like a linear equation at first glance, where we have the amount, which is our y value, equals the principal, that's how much we put in, how much money was either saved or borrowed. So this here is P, right? Times the quantity of 1 plus the rate, and that is in decimal form, but that is also our M value. Okay, and then T, which is the time, and that T is our X value. All right, so if I were to put this in slope-intercept form, where this is the Y, right? This is the M, and this is the X. All right, I have to distribute, right? So it's going to be P R T is the same thing as is going to be the same thing as mx, and that's going to be plus our b value, which is going to be p times 1, which is just p. Okay, so all they did here, I wrote this term first, so it would be in the mx plus b format. So this effectively is y, which is our a term, equals mx plus b. Okay, so if I were to write this in like this format, in the simple interest format, I would just drop some numbers in, and I would get 8,500. So A, or the amount after compounding, or after the interest takes effect, equals, I don't want to make sure there's no X. There's actually not an X here as showing that is the X. Okay. But anyway, A equals 8,500. 8,500. And then times quantity of 1 plus R, which is the rate. This is 0.0225. All right, that's my slope, right? So 0.0225 times t, which is my x value, my horizontal axis value, my independent variable. Okay, so that's my equation that I would use. Okay, to put this in slope-intercept form, right? Remember, this is my y, right? So all I have to do is distribute this 85 into there and into there. Okay, so I'm going to put it in with the mx plus b form first. So what is 8,500? 85 or 85,000? 85,000 times 0.0225 equals 19 or 1912.5. Right? So this is going to be 19. So A, funky A. All right, so A equals 1912.5 times the rate. Well, we already did that. Okay, so we did 19 times 0.225 times time. So this is my M, and this is my X value, right? And then my T, or my Y, my B value is just going to be 8,500, because 85 times 1 is 85, 85,000. 85,000. All right, so that is my mx plus b form. Okay, let me a little bit neater. Hard to write with a mouse. Okay, so that's that. All right, now I'm going to complete the table. Well, the y-intercept, we already said, was 85,000. 85,000. And what is this? And it's the when the loan begins, this is how much we borrowed. Why did that do that? I wanted it to do this. Okay, this is how much was borrowed at time 0. At t equals 0, 85,000 was borrowed. BORROWED. Okay, now what is the slope here? Well, this is my x value, right? So my slope is on 912.5, right? And it's that's how much the loan grows. Loan grows each year. So how much does it cost to maintain this loan each year? It's $1,912.50, right? So if it took how much interest, or what's the total have to pay if it's a 5-year loan, right? So we're going to put the total, which is the amount total, equals 1912.5 times 5. That's how much interest is going to be paid on top of the 8,500 that I initially borrowed. So if I multiply those two together, it's going to be equal to $9,562.50 plus the 8,500, which is going to be equal to 94,560. No, let's delete it. Delete it. $9,562.50. So over a 5-year loan, the interest costs that many dollars per year over that many years added to the initial, and it's going to be that much total, right? So here's going to twist it around a little bit. This is my A value. Figure out the time, right? How many years it took to figure out the time. So A was let me grab this thing, is 109,000, and that's going to be equal the 1912.50 times the time, right? And then plus the 85,000. Right, so now I got to figure out how much, what t value is, solving for t. All right, so we're going to take this over here. Let's make it a little bit neater. Take this over here, this value, this positive 85, take it over there, right? So this is going to be minus 85,000. All right, so if I do that, that's gone on that side. So this is going to be, let's see, it's 109. minus 85 is 24,000. So 24 $1,000 in interest alone, right? Because this is the principal, this is the total. So the difference between the principal and total is the interest divided by the 1912. 50 is the time. So let's see. Divide that by 1912.50. And we get approximately, I didn't do that right, hold on, 24,000 divided by 1912.5 is approximately 12.5 years. Is approximately 12.5 years. So a little bit more actually. So it's actually 12.549. So at it's like 12 or 12 years, 6 months, and like a couple days. But that's okay. You can say almost 13 years is approximately how long it takes to pay off the pool interest. Okay. So here we go. For this one, it's the same concept. All right, same concept, so I'm not going to go over that too much. It's the same process that we use for this one. So I hope that makes sense. Simple interest is simple. Okay, it's a linear equation. And you have to identify what the R is. So this I said was this R is the slope. It's actually not the slope. It's the slope divided by 85,000. So divided by P. But either way. All right, so hopefully that works out. If you guys need me to help you with this one in class, go for it and ask.